And guys, the topic for today is to solve systems by elimination. In the example one, we have to solve a system of equations by adding. So we have the exercise 2 times a number x. So we have 2x plus a number y. This is going to be equal 8. And later we have the other part that 4 times the number x. So we have 4x minus the number y equal 4. Okay, so we are going to solve the first exercise. The first one is the easiest one to solve. We find the solution immediately. Step 1 and 2, okay, then we have 2x plus y equal 8. Remember, we write the system of equations. 2x plus y equal 8. And for the other, you have 4x minus y equal 4. Okay, I think that you can see the system of equation in there. Then the step 1 is this, okay, to write the system of equations. So the step 1 is this one. When we identify the system of equation, 2 times one number x plus a number y. This is going to be equal 8. And later the other one, 4 times a number x minus a number 1 is equal, a number y, sorry, equal 4. Okay, so now that we identify this in the step 1, we need to eliminate one variable. We are going to eliminate one of these variables. And which one of them we can eliminate? We are going to add or subtract in a vertical way, okay? Like you learned in the elementary when you were starting to solve the operations in that way, okay? X with x, y with y, and 8 with the number 4 that they don't have any variable. Okay, so you identify that one y is positive and the other y is negative. So when you add this is going to be 0. Y plus negative y, then it's a subtraction because they have different signs. So this is going to be 0, but for x we have a result. 2x plus 4x is going to be 6x. So if you want, I'm going to copy again in here. So 2x plus y equal 8 and 4x minus y equal 4. And we solve the operation. 2x plus 4 is 6x. Positive and negative y, they are going to eliminate. So we have 0 in here. And this is going to be equal 8 plus 4, that is going to be 12. So if you want to eliminate, you can do it because 0 is not going to affect the equation. You can have then 6x equal 12. In the other step, you already know it. When we have one number multiplying the variable, we pass it to the other side to divide to obtain the value for x. So what is going to be the value for x? 12 over 6. Then the value for x is going to be 2. Okay, this is the value that we have in the first step. And later we are going to use this value, x equal 2. I'm going to write it in here. X is equal to, so I can eliminate this value. Then you can use this value to obtain the other one for the variable y. You need to replace the value for this variable in one of the equations, but you need to decide what equation are you going to use, okay? So if, for example, we use the first one, you can see that we don't have any term multiplying the variable. And the term that is multiplying x is 8, 2. Okay, so I think that for the positive numbers and all the things, the first one is easier to work with. So if we take the first equation, we have that 2x plus y equal 8. Then we need to replace that x is going to be positive 2. So 2 times 2 plus y equal 8. Okay, so a summary about this. We have the system of equation. The method is called elimination because we are going to eliminate one of the variables. Okay, I eliminate the variable y. So I only have one variable to work and I can find the value for this variable. Once we have the value for the variable, we use this to obtain the other variable, okay? We are going to work first with one and later we obtain the other, okay? I already have that x is 2, so I replace it in the equation. 2 times 2 is going to be 4. 4 plus y equal 8. And you pass the 4 that is in addition to the other side to subtract, so you have that y is equal 8 minus 4. So 8 minus 4. And you say that the result is only the subtraction of these two numbers, okay? So finally we obtain that y is equal 4. And this solution is the ordered pair that contains the value for x and for y. 2, 4. This is the solution. Important that when we obtain this possible solution, we need to check. In the book, they don't check. Maybe I think that they assume that you know it, that you need to check the answer. But to be sure that this is the solution, we need to replace it. So if you already copy, I'm going to erase the first part so we can check if this is the answer.
Mr. I have a question. I get lost in the part where it says 6x equal 12. Why you put 12?
8 plus 4. You add.
Okay.
You add in vertical way. This one plus this, the other plus this one. And okay.
Mister,
Mm-hmm.
now that we are in that step, what happens if I subtract instead of add, or there will be any exercise that we'll need to subtract or add?
Okay. The idea is to eliminate one of the variables. In here, it's so easy because the equation already give you one positive and one negative. But if you identify that, for example, you have positive at the beginning of the problem, we need to change it, okay? So in the example 2 and 3, we need to modify the exercise so we can eliminate one variable. But you need to eliminate the variable. So if you don't obtain it so easy, you need to modify the equations so you can eliminate, okay?
Okay, and in this topic, the only thing that we will do is to add vertically, or we'll have any exercise that we will be like subtracting, just adding.
Add or subtract. In this case, for example, they say addition because you start with a positive in here. We have another one with subtraction, the second example, that we need to multiply by a negative all the terms of one equation. And we have other terms that we need to multiply. We need to multiply by other numbers. So this is for your convenience. You need to find one way to eliminate one of the variables. So when you see the system, you need to analyze how are you going to do it in this case.
Mister, so if one exercise begins with multiplying, so in all the exercise we will be multiplying vertically.
Not in all the exercise, in one equation of these two, okay? You modify one, but if you modify one equation, you need to modify all the terms, the x, the y, and the independent term, okay? So, again, you obtain the 12 and you pass the number that was multiplied into divide, so we obtain the first variable. When we obtain the first variable, we can use the first equation or the second one. It's up to you. I choose the first one, and in the book I write the first one because it is the easiest one. It's positive, you don't have any number multiplying in here. In here you only multiply by 2, so it's the easiest one to solve. You find the other value for the other variable, in this case y equals 4. And when you have the order pair 2, 4, you can check. How are you going to check? You are going to replace the value for x and the value for y in both equations. So I'm going to eliminate this part. I'm going to erase. I'm going to erase so I can show you how to prove if this is the solution or not. So the first example is 2x plus y equal 8. So you replace the values. 2 times 2, 2 is x, right? Plus y, that is going to be 4. This has to be equal 8. Look that I'm taking the equation in the same form that appears, only that I replace the values for the variables x and y, okay? 2 times 2 is 4, plus 4 equal 8. Yes, right? So I check that for the first equation, that's true. So this ordered pair is a solution for the first equation. But I need to try now if the same ordered pair is a solution for the second equation. Because this ordered pair has to be a solution for both of them, not only for one, okay? If we find that the solution we obtain is only for one of the equations, then we did something wrong in the step 1 or 2. So we need to see what mistake we did, because the solution, when we find it, has to be for both equations. So for the second one, 4x, so 4 times 2, minus y, minus 4, equal 4. 4 times 2 is going to be 8. 8 minus 4 equals 4. Yes, right? So we can say that the order pair is a solution. So this is a solution. We are sure now that this is the solution. Maybe you cannot write because the letter is so small, but in here says that is a solution, okay? And so this is for the first one, okay? Later, if you already copy this part, or let me know if you have any other question about this first one. If you don't have any other question, we can go to the second one. In the second one, we have something different, okay?
Mister, I got lost when you check. When you check, what you need to do is like you need to make the equations in that. And if we got the same answer, it is correct.
When you check, you replace both variables and you obtain that one part of the equation is completely equal to the other part, okay? So, for example, in the first one, we replace the values. We obtain one statement that is true. 4 plus 4 is going to be 8 for the first one. For the second one, for example, 8 minus 4 is going to be 4, okay? So what are you trying to check? If the solution fits in the equation correctly, okay? If the statement is true. So, okay. Then for the second one, we are going to read it. Hannah is helping her younger brother to learn to count money. She gave her brother a total of 20 coins, nickels and pennies. Okay, so we are going to define what equation and what variable is for the nickels and what variable is for the pennies. We need to write it, okay? So solve the system equations to tell whether he counted the money correctly, because he counted $0.68, okay? So I'm going to write the system of equations. I need to erase this. You already have it on the book, so you don't need this part. Remember, guys, that in these systems, what I'm trying to do is to work easily. So if I can eliminate one variable, like in substitution, for example, if you remember in substitution, we isolate for one variable and later we replace it in the other one, okay? So this is the idea of this, not to work with both variables. Okay, then we can continue with the other system of equations. I need this to write it. X plus y equal 20. I'm sorry, this went so bad. X plus y equal 20. And the other one is x plus 5y equal 68. Okay, then x are the nickels, right? X are the pennies. We need to write what means each one of them. And y are the nickels. Okay. The number of pennies plus the number of nickels equal 20 because she gave to her brother 20 coins. So in total, she has 20 coins. And this is for the amount of money that he counted in dollars, okay? So we have two different equations, one for the number of coins and the other one is for the amount of money, okay? You can see that in this system of equation, it's not so easy to eliminate the variable. Both of them are positive, so if I add, they are going to be 2x, so they don't eliminate. In here, if I add, you have 6y, so they don't eliminate. In here, okay? So we need to change the sign of this one. You need to modify the equation. I'm going to multiply by negative. This second one, only that if you multiply by a negative sign in here, you need to modify all the terms. So you have x plus y equals 20. And for the second equation, negative x minus 5y equal negative 68. So if I decide to multiply one equation, I need to multiply all the terms, okay? If I only change, for example, for x, that is what I need, the exercise is going to be wrong because you are going to find one value different for the other variable, okay? So if we decide to modify, we need to modify all the equation, okay? Until this part, I think that we are clear. It's like you multiply by -1, right? You can multiply by -1, or you can say that you multiply by the negative, okay? It's the same. It's like multiplying by -1 because you only need to change the sign, okay? Or you decide it's easy if you think that you only need to change the signs, okay? So if you need to change it for x, you change it for y and for the term without any variable, okay? Now we can subtract, okay? X minus x is 0. Look, I'm trying to eliminate one variable and I already did it. I already eliminate the variable x. In here we have -4y because -5 plus 1, -4, and copy the variable y. This is going to be equal -68 plus 20, or in the opposite, 20 minus 68. That is going to be -48. Okay. Then we have that -4y equal -48. I can eliminate the 0. I don't need it in here. Okay. So you only know that this is going to eliminate with this one. Okay. Then I have that y is equal -48 divided by -4. Okay. The -4 that is multiplying my variable, I need to pass it to divide. Look, that is -4 multiplying the variable. It's not a subtraction. It's not 4 minus y or something like that. The -4 is complete multiplying the variable. So I pass it, including the negative, to divide, okay? Then One number that multiplies 4 times is equal to 48 is 12. And negative divided by negative is going to be positive, so I obtain positive 12. Okay? We have the value for the first variable, then what we need to do is to use this value to obtain the other value. Okay? So we have that. If we use the first variable, is the easier, I think. So if we have x plus 12 equal 20, then x is equal to 20 minus 12. X equal 8. So the order pair that we obtain is 8, 12. The value for x and the value for y. Okay. So I think that we have 3 minutes, so we can finish the last one. Okay. The last one is easy, like this one. So if you already have it, I can eliminate this. I'm going to erase. Sorry, eliminate is the name of the method. So. The last one, I'm going to copy the exercise. Example 3, I copy the system to L plus 2W equal 26. And the other one is L minus W equal 3. And why is the system of equation like this? The difference of the length and width of the rectangle is 3 centimeters. You can see that one side of the rectangle is L and the other side is W. The vertical parts are W. We have 2 sides that are L and 2 sides that are W. Equal 26 because 26 is the perimeter, but the perimeter is the addition of the sides of the rectangle. And you can have the perimeter equal 26 in the bottom of the drawing. And for the other part, it's because the length minus the width equal 3. They give you these facts, so you write the system of equations. 2W, 2L, sorry, and just 1 in here. In here I have 2W and just 1 in here. So by what number you need to multiply in here? Obviously by the number 2, okay? So you can eliminate one of the variables, and the variable that is going to be eliminated is W, because you have one positive and one negative. So to your convenience, you choose the number that you are going to use. Only that, again, when I choose one number to modify the equation, I need to multiply it by all the terms. So if I multiply this to L minus 2W equal 6, because 3 times 2, okay? Now we solve the addition or subtraction depending on what we have on the operation. 2 plus 2, we have 4L. W and W, they are going to eliminate each other because they have one positive and one negative. This is going to be equal 32 because, okay? In here is plus 0, so we don't need this part, okay? So 4L equal 32. L is equal 32 over 4. So L, you know that is going to be 8. And, okay, what are you going to do to find the other value? You only replace the value that L is equal 8. In this equation, that is the easiest one. If you choose the first one, you need to multiply by 2 in all the terms, so you need to are going to complicate it so much. I choose the second equation. The second equation is L minus W equal 3. L is 8. 8 minus W equal 3. Then you have that negative W equal 3 minus 8. Because we pass this to subtract to the other side. Negative W equal negative 5. we solve this subtraction. 3 minus 8 is minus 5. And the negative that is affecting your variable is going to pass to the other side. So the 5 is going to change from negative to positive, okay? So W is equal positive 5. Then what is the solution that you have? The order pair that we are going to copy is 8, 5. You always write the order pair inside the parentheses with the solution for x and or y, okay? So this is the answer that we obtained for this example, for the number 3, okay? Find the solution and use it to find the other variable, okay? So we work first with this one, and you multiply in here to your convenience so you can eliminate one of the variables, okay? So I don't know if you have some questions about this. If you don't have any questions, we can finish, okay?